All right, so recording has started. I'll share my screen. Okay. Very well. So I'll repeat the previous lecture once again because it's very important, and I want you please to implement everything. We've implemented the examples, and we showed how to do this, but I want you yourself to do it again, please, and make sure that the programs that we've written are working without any errors or anything. So we'll talk about abstract, or we talked already about abstract classes and polymorphism. And the difference between them is very easy. Abstract is just to hide some information and show only the essential information. So let's start screen sharing, slideshow, and we will see. And also to remind you, this is the second time we are explaining this topic. So we'll start with the abstract. So abstract class or abstraction process is displaying only the essential information and hiding, sorry, what's happening? And hiding the details. Just like in your case, when you are using your cell phone, you use it for phone calls. I don't know what's going on. Phone calls or texting or whatever, use browsing, etc. You only use the screen, all right? The screen, you touch the icons, you send message, you use the applications, but you are not aware, or you don't care about what's going inside, about what is the content of the memory, okay, how the processor process the information, how the signal transferred from one place to another. All these things are hidden. So the abstract is showing only the essential information, and you don't need to bother yourself with the other information. The other example, or another example, the car driving a car. Now the driver can start the car, yeah, it can put the key in the ignition and start it, and that's it, or even push the button and start the car and then shift the gear, press the on the pedal, the accelerator pedal, and of course using the steering wheel to drive the car. But he or she doesn't know or doesn't care. Actually, some people are aware of what's going on inside the engine and other parts, but here he doesn't care or she doesn't care about what's happening in the engine or in the gearbox or in other parts. He needs or she needs only to drive the car, and that's it. So we can say that the available information is exactly what the driver needs. There's no need to display, for example, or to show how the engines, the cylinders, etc. Okay, so the same idea here in the class. In the class, we need to hide all the details and display only the essential information. Okay, how is that, or how to achieve that? So let's just read this slide. Another displaying only essential information and hiding the details. In other words, class and functions outside the class can only see the essential information, and all other details and information are hidden. And this is the example of the car. Now, for example, we took this and we implemented this example. The function here, I'm going to define a basic class. I'll call it shape, all right? And we've done this in the inheritance. But the new thing here we are using virtual function. We call it pure virtual function, all right? Why pure? Because it starts with virtual and ends with equal 0 without any definition. Why we do this? Actually, the function virtual double get area, okay, is defined as virtual, and again, I will correct it here as pure virtual function. All right, pure virtual function. Why pure? Because it's equal to 0. All right, that means all the classes that inherits the class shape should define a function inside the class itself, and the name should be get area. Should put the definition. If you don't put it, then we'll get error for sure. All right. So it's defined as a pure virtual and equated to 0 to make it mandatory for all derived classes to define it inside the class. So if I, for example, define a class rectangle, I think there's an issue with this. I'll display, or I'll use the regular PowerPoint. All right, so here, as we said, if I define a class rectangle, and you know what this does this column mean? It means it inherits shape, and of course here, since it's not our concern now, it will be public. All right, public shape. All right. Now, whatever you write here, no problems at all. You can write whatever you want, but you should have a function called double get area. Okay, and a definition here. If you don't get this, then you'll get error. Why is that? Because I equated to 0 here and made it mandatory that every class inherits this class should have a function called get area, and it should define it. Okay, this is very important to remember. I want you to keep this in your mind, and please make it as one of the facts that you believe in. All right, so virtual double get area equals 0 means that every class inherits this class should have this definition. All right, so for example, this one, class rectangle, public shape, it inherits shape, public double get area return W times H. All right, class triangle, also public shape, it should have the definition public square, sorry, class square, public shape, also it should have, of course, don't get confused, although we have the same name, but we have different definition, which is called overloading, and this is what we will talk about it very soon. All right, so rectangle, triangle, and square are derived classes from the shape class. They inherit all the members of the class, but each one should include a definition or different definition for the virtual function. This is the full code, and I shared with you. I shared it. It's editable. You can copy and paste it. All right. We've written this code last lecture. So let's see here the overall program. We have class shape, protected H, and which is the height and the width, and public set H and set W. Why we need public? Sorry, we need this because here they are protected. We cannot use dot X or dot Y. You will get error. Or sorry, dot H or dot W. You will get error, and this we discussed in the access modifiers. All right. Now here also I have virtual double get area equals 0. As again, this is to make it a pure virtual, and it's mandatory for all derived classes to define it. If you can see here, rectangle, public shape, all right, or the rectangle is a subclass of the shape and inherits everything. But here, it should define the gate area, return h times w, etc. Class triangle, also the same thing. So here, if you can see in the main function, rectangle r dot set h. But now if you can see, r doesn't have set h, right? Because it inherited it from the shape. Also, r dot set w, also it's inherited from the class shape. Triangle t dot set h, t dot set w. Now the area of the rectangle is r get area. Okay, then it will go there to the rectangle and finds that get area returns h times w. In this case, 5 times 7, which is 35. So it will print 35. In the other instruction, t dot get area, it will see that t is what? Is a triangle. So it will go to triangle and returns h times w divided by 2, which is 17.5, I guess. Okay, and prints this. So in general, to summarize everything, I have class, shape, superclass, all right, which defines virtual or pure virtual function, okay, that we called it get area, that all the derived class, for example, here I have rectangle, should define it, should have get area with definition. And also I have triangle, okay, also should define get area. Okay, this is simply the virtual function. Now talking about the polymorphism, the word is not in English. It's, I think, in Greek. Okay, it means using the things more than once. All right, and I think you have now you have the idea that what we are going to talk about, to use the same function, okay, but with different meaning, with different number of parameters, all right? So using functions with the same name, but with different functionality. For example, the function double area of double h w w can be used for different functionality depending on the shape class which uses. All right. In other words, if the shape is rectangle, it should return hw, and if it's triangle, h times w. Exactly what we've done here. All right. The polymorphism has different types. First, it has two types: compile time and runtime. What's the meaning of compile time and runtime? When you write the code, this is your source code. If you remember at the beginning of the course, we said you write something like a.cpp, right? This is your source code. Then this code is compiled to object code, then linked. If you don't remember, please go back to the first lecture. Then linked to get exe file. Then this exe file will be executed. Okay, so the compile time here in the compilation and linking, while the runtime, it means during execution. Okay, so there are two types. We have compile time and runtime. Now in compile time, function overloading. We can overload the functions to have the same name but with different operations, and we can have operator overloading. If you remember, we defined the class point, okay, which is point.x and point.y. Okay, now We can overload some operations such as plus, minus, division, multiplication, okay, such that I can define, for example, point P1 and P2. I can use P3 equal P1 plus P2, but with different meaning than the regular addition. In integer, if you say integer x equal 5, integer y equals 7, integer z equal x plus y, it will add 5 plus 7, that means z will be 12, right? But here I can define or overload. Overloading means I'm going to use the same name, the same symbol, but with different operations, different meaning. All right, we'll talk about it. We'll take example also. So here I have two kinds of overloading, which is function overloading and operator overloading. Runtime overloading is the virtual functions that we've discussed already. So actually, in abstraction, we use the virtual function, but here it's also considered part of the polymorphism and it's of type runtime. If you get back here, exactly this is what we did. I have here get area, but with different functionality, right? Here is different than this. You may say, as if the number, the names, there will be no more names. I can call this, for example, get area 1 and get area 2. Actually, you can do it, but this will not satisfy the abstraction and polymorphism principles. So it's better to have the same name with different functionality. All right. So this is the polymorphism, and let's take an example of compile time function overloading. We say in compile time we have function overloading and operation overloading or operator overloading. Okay, so see here, I have class A, public, void print integer x. See out the value of x is x, end line. Void print of double. See, I'm using the same function name, right? And there will be no errors, by the way. So here I'm passing integer. Here I'm passing double. Here I'm passing two elements. Not only the type, the number also can be changed. So void print of double x, see out x, the same thing. Void print of integer x, integer y, so see out value of the values of x and y are x and y. Here I would define A as an instance of the object or the class A, then A.print of 5. Now, it will check and find 5 is an integer, right? So it will go and search for the appropriate function. In this case, the first one. Here it checks and finds 22.15. That means it's double. Then it will go and execute this one. Here it finds that I'm passing two arguments. Then it will go and execute this one. And of course, you can, for example, define another function, print character or print string. Okay, so that's why now in cout, when I pass x, if x is integer, it will print it as integer. If it's double, it will print it as double, and so on. Because there's an overloading here, and you can use the same name of the function with different types of arguments and different number also. All right. So a function with the same name but with different number and or type of parameters. All right. Compile time, I will keep it for next lecture. We'll continue on the next lecture because you need to be ready for the quiz. The quiz will be available in a few minutes. So please just be ready. Do it yourself, okay? Don't rely on others because as I told you, in the final exam, there will be no how say it, no multiple choices, all right, and no true false. You have to write everything yourself, and you have to answer all the questions yourself. So it's a good idea to start practicing, or to rely on yourself. So I don't think we need to record the rest of the lecture to avoid having a very long lecture. You can access now the quiz